Okay, students, so let's start with the theory past papers for kinematics, and this is applicable for both O levels and IGCSE physics. So let's see this first question. Figure 1.1 shows the speed time graph for a car traveling on a straight horizontal road. Describe the motion of the car shown in figure 1.1. Okay. So you have to describe this motion of the car shown on the speed time graph. If you notice, this motion consists of two things. One is this straight line motion, and then we have this curved motion like this. We will have to define both of these motions to get a 2 on 2. So what we can do? We can say that car is traveling, car is traveling at a constant speed, at a constant speed. And what is that constant speed? That constant speed is of 18. The car is traveling at a constant speed of 18 ms minus 1 from t is equals to 0 seconds to t is equals to 10 seconds. The car is traveling at a constant speed of 18 from 0 till 10 seconds. And from t is equals to 10 seconds till 50 seconds, the car is decelerating. From t is equals to 10 seconds to t is equals to 50 seconds, the car is decelerating. The car is decelerating. Okay. And if you are an A star student, you will also tell the value of deceleration. If you are an A star student, you will also tell the value of deceleration. Okay, how can you calculate the value of deceleration? You can take the starting point on the curve, that is x10, y18, and you can take the ending point on the curve, that is x50, y is, let me zoom in a bit, y is 2.5. Okay, y is 2.5. You have 2 points on the curve. Can you calculate the average deceleration? Yes, you can do that. How will you calculate the average deceleration? Very, very easy. Y2, that is 2.5, minus y1, that is 18, divided by x2 minus x1, that is 40. Your deceleration comes out to be negative 0.375 ms minus 2. So you can say from t is equals to 10 to t is equals to 50 seconds, the car is decelerating at an average deceleration, at an average deceleration of 0.3875 ms minus 2. Okay. At time t is equals to 10 seconds, the engine of the car is switched off. Okay. At time t is equals to 10 seconds, let me erase some of the things from here. At time t is equals to 10 seconds, the engine is switched off. So somewhere here. Yeah. The engine is switched off here. Name two forces that act on the car to change the motion, to cause the change in motion after 10 seconds. Okay. Why is the car basically decelerating after 10 seconds? The examiner is trying to ask us. So, as you switch off the engine, the forward force vanishes, and then there are only two forces left. That is the friction between between the car between the car and the road, between the car and the road. And what else is acting once the engine is closed? Air resistance on the car. Air resistance on the car. Okay, let's see a part 2. Suggest why figure 1.1 is a curve after 10 seconds. Okay. Suggest why this is a curve. That's very easy. So to answer this question, although this is a one marker question, but let's study a diagram for this. Let's say this is your car. Let me zoom in a bit. Let's say this is your car. Initially, there was a backward force. Let's say friction acting. Okay, let me make the friction with the tires. That will be more Logical. Initially, there was a frictional force acting and an air resistance force acting, somewhat like this. And there was a forward force. There was a forward force on the car, like this. There was a forward force, you can say the engine force on the car. But after 10 seconds, as you can see, after 10 seconds, the engine is switched off. If the engine is switched off, this means the forward forces vanishes. As the forward forces vanishes, only the backward forces or resistive forces are left. If the backward or resistive forces are only left, this results in a deceleration, or you can say a decrease in speed. Now, you have to suggest why figure 1.1 is a curved after 10 seconds. So, what will you say? You will say, as speed or velocity decreases, resistive forces, or you can say resistive forces, or you can say what? Friction decreases. Resistive forces or friction decreases. And as resistive forces decreases, and as resistive forces decrease, what will happen? Can anyone tell me? Your resultant force will decrease. As resistive forces decrease, your resultant force decreases. As resultant force decreases, your acceleration also decreases. Or a better way to say it would be your magnitude of deceleration decreases. Your magnitude of deceleration decreases. Now, I have written a lot of things. Let me explain it one by one. Okay. So, first of all, you must remember that resistive forces decrease as your velocity decreases. This is a general thing that you must know. This is something that you all must know by heart. That as your velocity decreases, your resistive forces will decrease. Oh, what has happened here? One second. Let me zoom out a bit. Yeah. As your velocity decreases, your resistive forces decrease. Please remember this. This is something that you must know by heart. Okay. Now, as your resistive forces decreases, your resultant forces also decrease. As your resistive forces decreases, your resultant forces also decrease. Why is that the case? Let me show you. See, what will be the resultant force after 10 seconds? Yes, can you tell me what will be the resultant force after 10 seconds? Only a sum of these forces. Only a sum of air resistance and friction. And as velocity decreases, both air resistance and friction will decrease. As both of them decrease, your resultant force will decrease. As resultant force decreases, have we studied this formula? F is equals to ma. If resultant force decreases, your acceleration magnitude or deceleration magnitude decreases. Simple as that. This is what I have written here. Let's further move on to the next question. Okay. Between t is equals to 10 seconds and t is equals to 20 seconds, the speed of the car changes from this to this. Okay, so let me increase the thickness here. Okay, so this is your initial speed, this is your final speed, and the time taken from 10 to 20 seconds is 10 seconds. Okay, the mass of the car is 1200 kg. Calculate the change in momentum of the car in this time. Okay. So what is change in momentum equal to? Change in momentum is equals to mass into change in velocity. What is your mass? 1200. Can you calculate the change in velocity? Yes. The final velocity is 11. The initial velocity is 8. Your change in momentum comes out to be 1200 into minus 7. This comes out to be negative 8400. And what are the units of momentum or change in momentum? The units for change in momentum are Newton seconds. So negative 8400 Newton seconds. Okay. Calculate the average resultant force exerted on the car during this time. Okay, we have to calculate the resultant force. So what is resultant force equal to? Change in momentum over change in time. What is your change in momentum? negative 8400. What is your change in time? 10 seconds. So divided by 10. Your resultant force comes out to be negative 840 newtons. So negative 840 newtons. Yeah, Newton ka unit is already written. Let's move on to the next question. An aircraft pulls a glider along a runway as shown in figure 1.1. Okay, so as you can see, this aircraft is pulling this glider at the back. One I am highlighting in yellow. Okay. Figure 1.2 shows the speed of the glider. Okay, this is for the speed of the glider during the first 12 seconds of the motion. Okay, this is the speed time graph. Describe the motion of the glider in the first 12 seconds. Okay. So if you can see, there are two things that we can describe here. This is the first motion and this is the second motion. This is the second motion. Okay. So what can we say? From time t is equals to 0 till time t is equals to 6 seconds, the glider is accelerating. And can we also calculate the value of acceleration? Yes, we can do that. This is 22. So this point will become what? X6, Y22. This will be what? 0, 0. Can you calculate the acceleration here? Yes, acceleration is equals to y2, that is 22, minus y1 over x2 minus x1, that is 6 minus 0. 22 divided by 6, this gives you an answer of 3. You can say 67 ms minus 2. So how will you write the first point? You will say from time t is equals to 0 seconds to time t is equals to 6 seconds, the glider is accelerating. The glider is accelerating with an acceleration of with an acceleration of with an acceleration of acceleration I hope yeah acceleration of 3.67 ms minus 2. Okay, second point, what will you write as the second point or to gain your second mark? You will say from time t is equals to 6 seconds till time t is equals to 12 seconds, your glider is traveling at a constant velocity of 22. You can write it here. From time t is equals to 6 seconds till time t is equals to 12. Okay. 6 to 12 seconds, the glider is traveling. The glider is traveling at a constant speed of 22 ms minus 1. Okay. In the first 6 seconds of the motion, there is a resultant force 1800. Okay, we are given the resultant force. Using the increase in speed in the first 6 seconds, calculate the mass of the glider. Very, very easy. Force is equals to ma. Have you calculated the acceleration in the first 6 seconds? Yes, you have already done that. That was coming out to be 3.67. Your force is 1800. Your mass comes out to be 1800 divided by 3.67. What will your answer be? Your answer comes out to be 490.9. This is roughly equal to 491 kg. Simple as that. Let's further move ahead. Determine the distance traveled by the glider in the first 6 seconds of its motion. You have to calculate the distance traveled by the glider in the first 6 seconds of its motion. So can you see here we are given the speed time graph? And do you remember one key point? Okay, let me erase these acceleration calculations. I hope you have copied this down up till now. Now, if you have to calculate the distance traveled in the first 6 seconds, do you remember area under the speed time graph is equals to distance? For the first 6 seconds, this is a triangle. How to calculate the area of this triangle? 1 upon 2 into the base, that is 6, into the height, that is 22. This becomes 1, this becomes 3. 66 meters is your distance traveled. So let's write it here. 66 meters. Obviously, you can copy the working from the top to the bottom. Here, like literally, it makes zero difference. The glider has no engine and stays in the air with the use of convection currents. Okay. State what is meant by convection currents. Okay, convection currents means what? Hot, less dense, air rises and cold, denser air falls to the ground. Falls to the, or you can say cold, denser air sinks. You can say that. Sinks. Simple as that. Suggest how the convection current supports the glider that suppose the glider is formed. Okay. You have to tell how the convection currents that are supporting the glider are formed. So basically, it can happen that on the earth we have some nuclear power stations or we have some hot sites, let's say volcanoes, etc., that give rise to hot air rising up and that will support the glider. You can say hot surfaces on earth, hot surfaces on earth, such as volcanoes, I can say volcanoes, yes, give rise to gave rise to hot air that rises to the top. Simple as that. Let's move on to the next question. Okay, a train travels along a straight horizontal track. At time t is equals to 0, the train passes through station P. Okay, at this point, it is at station P. Constant speed without stopping. Okay, the driver applies the brakes 70 seconds before reaching station Q. Okay, so you are at a station Q here. The train decelerates. Figure 1.1 is the speed time graph of the train from time t is equals to 0 until it stops at station Q. Okay, so let's first of all calculate the speeds at which this is traveling. So this is 60, and from 60 to 80 you have 10 boxes. So 10 boxes are covering 20 units. So one box on the y axis will be equal to how many units? 2 units. Simple ratio method. So this will be 77 ms minus 1 as far as I can see this. Okay, let's further move ahead. Use figure 1.1 to determine the distance between station P and Q. Okay, very easy. How can you determine the distance between station P and Q? You have just studied that area under speed time graph is equals to distance. How can you calculate this area? This area will be what? Area of trapezium. Okay, so how will you calculate this area of trapezium? Very easy. Very easy. This is your parallel side. This one. This. This is your first parallel side that is coming at a value of here, that is roughly 56 seconds, and this is your second parallel side that is 126 seconds. Yeah, so what are your two parallel sides? First marked in blue and the second one marked in yellow like this. These are your two parallel sides. Oh, come on. Chalo. Yeah, these are your two parallel sides. And what is your height? Your height is 77 ms minus 1. Okay. So, do you remember the formula of area of trapezium? The area of trapezium is equals to 1 upon 2 into sum of parallel sides into height. Okay. What is your sum of parallel sides? Very easy. 1 upon 2 into 56 plus 126 multiplied by height, that is 77. Can you calculate the answer here? 56 plus 126 multiplied by 77 divided by 2. This comes out to be 7007 meters. 7007 meters, or if you want to write it till three significant figures, you can say 7010 meters. Simple as that. Let's further move ahead. The train has a mass of this. Okay. Determine the deceleration of the train in the last 70 seconds before it stops. Okay, you have to determine the deceleration in the last 70 seconds. Very easy. Calculate this point. This is x-axis 56, y-axis 77. And this point is x-axis 126, y-axis 0. Can you calculate the gradient with these 2 points? Yes, you can surely do that. Let's increase the thickness so that it shows on the graph. You will say y2 minus y1, 0 minus 77 divided by x2, that is 126 minus 56. This comes out to be minus 77 over 70. This, I guess, will come out to be 77 divided by 70, 1.1. Negative 1.1 ms minus 2 is your deceleration. Oh, is your deceleration. 1 second. Yeah. So your deceleration will be 1.1 ms minus 2. Now, an important thing to note here is, since we are asked about deceleration, we will ignore the negative sign and we'll just give the magnitude, because deceleration already accounts for the negative sign. Calculate the resultant force on the train. Now we have to calculate the resultant force on the train. I think this will do the job. Resultant force. Force is equals to ma. Your acceleration is 1.1, or you can say deceleration. What was your mass? 3.8 into 10 raised to the power of 5 multiplied. So let's do one thing. 3.8 into 10 raised to the power of 5 multiplied by 1.1. 3.8 into 10 raised to the power of 5 into 1.1. This comes out to be what? 418 into 10 raised to the power of 3 newtons. Simple as that. Let's further move ahead. Let's see this. Although this is slightly blurry, but I hope the video quality will justify this. Okay, so let's move on to this question. Figure 7.1 shows a child sitting on a sledge on a snow-covered hill of constant slope. Okay, this is a child sitting on a sledge. This is his brake. This is the snow-covered hill. This is the wall. Okay, perfect. At time t is equals to 0, the child and the sledge begin to move down the hill in a straight line. When the child sees a wall ahead, he applies the brake. Okay. The child and the sledge continue to travel in a straight line until they come to a stop before hitting the wall. Okay. So, when the child sees a wall ahead, he applies the brake. Okay. The child and the sledge continue to travel in a straight line until they come to a stop before hitting the wall. Okay. This is the speed time graph for the journey. Okay. The brake is applied at 26 seconds. So basically, somewhere here, 26 seconds, maybe this value. And what will be the speed at this value? Let's calculate that as well. So it is two boxes from the top, that is this value. Okay, so 10 boxes are covering 4 units. One box will cover how many units? 0.4 units. So this will be 15.6 and 15.2. Yeah, so the velocity initially is 15.2. Let's see if we need that or not. Okay. Figure 7.2 shows the speed of the child and sledge varies over the whole journey. Okay, we can see that. Explain why between time t is equals to 0 and time t is equals to 26 seconds, the speed varies in the way shown by the graph. Okay. So we have to tell why the speed is varying in this manner. 1 second. We have to tell why the speed is varying in this manner. Okay. So if you have a keen eye of noticing things, this is the typical speed time graph for what? This is a typical speed time graph for terminal velocity. Okay. Now what used to happen in terminal velocity? You need to write it here step by step. You will say initially, 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 the sledge, the child and the sledge, you can say. The child and the sledge are starting from rest, are starting from rest. Should I increase the thickness? I guess yes, I should. But then if I increase the thickness, oh, it's quite the it's more difficult to like adjust the thickness of the pen than to answer these physics questions, because if I increase the thickness it wouldn't come inside this box. Okay, initially the child and the sledge are starting from rest. Okay, this causes resistive forces resistive forces to be 0, and acceleration is maximum. And acceleration is maximum at the start. At the start. Okay. As the speed increases, as the speed increases, resistive forces increases. Resistive forces increases. What will this do? This causes your resultant force to decrease. This causes your resultant force to decrease. As resultant force decreases, acceleration start to decrease. Acceleration starts to decrease. Now, here is how an A star student will write the next point. Now, an A star student will look for a point where the velocity has started to get constant. An A star student will look for a point where the velocity has gotten constant. Maybe round about. If I remove this highlighting, you can see a better look. Maybe at this point. At this point. Yeah. An A star student will say at roughly 22 seconds. Yeah. An A star student will say at roughly 22 seconds. Can you see here what is happening? The velocity has gotten constant. It has become horizontal. So the final point by an A star student will be at time t is equals to 22 seconds, the forward force equals the resistive force, equals the resistive force. Hence, acceleration reduces to zero, or you can say drops to zero, and the child plus sledge reach a constant velocity or a speed of 77, I guess, right? The constant speed, no, the speed constant was a 15.2. I guess 77 was for the previous question. Reach a constant speed of 15.2 ms minus 1. At time t is equals to 26 seconds, the front of the sledge is 35 meters from the wall. Okay. So at time t is equals to 26 seconds, somewhere here. Yeah. The sledge is 35 meters from the wall. Okay. Somewhere here. Okay, let's see what the examiner is asking. Determine the distance between the front of the sledge and the wall when the sledge stops. Okay. So at t is equals to 26 seconds, the sledge is, let's say, 35 meters away from the wall. We have to calculate how much will be away from the wall when it has finally stopped. So what can we do? We can calculate the area under the graph. We can calculate this area under this triangle. Maybe this. Yeah. This entire triangle. We can calculate the area under this entire triangle. How will we do that? 1 over 2 into the base, that is from 26 to this is 30. So base is 4, height is 15.2. This will be what? 4 into 15.2 divided by 2. The distance traveled comes out to be 30.4. Okay. So after 26 seconds, it is further traveling a distance of 30.4 meters. Okay. What will be the distance left? 30 minus 30.4. This comes out to be 35 minus 30.4. Sorry. This comes out to be 4.6 meters. Simple as that. Okay, let's further move ahead. At time t is equals to 26 seconds, the sledge and the child begin to decelerate. Obviously, it is evident from the speed time graph as well. Determine the size of the deceleration. Okay, how will we determine the size of the deceleration? Very, very easy. Take 2 points here. The first point is time t is equals to 26 and the speed is 15.2. The second point is here. X is 30, y is 0. Can you calculate the deceleration? Yes. Y2, that is 0 minus 15.2. And this is x2 minus x1, that is 4. So 15.2 divided by 4, this comes out to be negative 3.8 ms minus 2. And obviously, I have also stated this earlier as well. If the examiner is asking for deceleration, the negative sign is already accounted for. You just have to write the magnitude. The mass of the child is 46 kg and the mass of the sledge is 9 kg. Okay. Determine the resultant force as the decelerate. F is equals to ma. Mass will be 46 plus 9 and this will be 55. 55 multiplied by answer, you get 209. Mass is 46 plus 9 multiplied by 3.8. This gives you an answer of 209 newtons as your resultant force. Simple. State the energy transfer that is taking place as the sledge and the child decelerate. Okay, what is the energy transfer that is taking place as the sledge and the child decelerate? As the sledge and the child are decelerating, can you see gravitational potential energy is decreasing as it is losing height? Kinetic energy is also decreasing as it is decelerating, velocity is decreasing. These two things get converted into thermal energy. You can write this down. You can say loss in kinetic and gravitational potential energy, loss in kinetic energy and gravitational potential energy and gravitational potential energy gets converted into what? Potential energy gets converted into thermal energy. Simple as that. Into thermal energy. Okay. At time t is equals to 26 seconds, when the brake is applied, the child jerks forward on the sledge. Why does this happen? At time t is equals to 26 seconds, when the brake is first applied, the child jerks forward. Why? Because the mass of the child resist change in motion. This is what? Due to inertia. The mass of the child resists change in motion. Simple as that, nothing complicated here. Let's move on to the next question. Figure 7.1 shows the speed time graph for a car traveling on a straight horizontal road. Okay. Describe the motion of the car, a three marker question. So basically, you have three motions here. First is this line. Second is, let me highlight this. Second is this line. And the third is this line. Yeah, somewhat like this line. So let's describe them one by one. First and foremost, what will you say? From time t is equals to 0 till time t is equals to 10 seconds. You will say from time t is equals to 0 till 10 seconds, the car, is it a car? Let me see. Yeah, it is a car. The car is accelerating with an acceleration of what? With an acceleration of. Let's calculate the acceleration value as well. This is 0, 0, and this point is x10, y16. Okay. So y2 minus y1, 16 divided by x2 minus x1, 10. This comes out to be 1.6 ms minus 2. So from time t is equals to 0 till 10 seconds, the car is accelerating with an acceleration of what? 1.6 ms minus 2. What will be your second statement? From time t is equals to 10 till time t is equals to 20 seconds. From time t is equals to 10 till 20 seconds, the car is traveling is traveling at a constant speed of what? At a constant speed of 16 ms minus 1. You have up till now scored 2 marks out of 3. Just the last motion is yet to be described. Let's say this is your point 1, this is x20, y16, and this is x24, y0. Can you calculate the deceleration here? Yes, 0 minus 16 divided by 4. This comes out to be negative 4 ms minus 2. You can further say from time t is equals to 20 seconds till 24 seconds, the car is decelerating with a deceleration of what? With a deceleration of 4 ms minus 2. Simple as that. Let's further move ahead. Use figure 7.1 to calculate the distance traveled by the car during the 24 seconds of motion. Show your working. Okay. So if you see, let me erase some of the things. Let's erase this. Let's erase this. Let's erase this. If you and you can also erase this acceleration part as well. Yeah. You don't need this working anymore. You have already written what you have gotten. So if you see, this graph can be divided into two halves. One is a trapezium like this. Let's say this is your half A, this is your shape A, this is your shape B. You can divide this graph into two halves. One is a trapezium, one is a triangle. Let's calculate the area of A, that is a trapezium. The area of A is equals to what? 1 upon 2 into sum of parallel sides. What will be the parallel sides? The parallel sides are this, that is 20, and actually this color is pretty weird, and this, that is from 10 to 20, that will also be 10. This parallel side is 10, this parallel side is 20, the height is 16. So area of shape A is easily calculated. 10 plus 20 into 16. This becomes 1, this becomes 8. This equals to what? 30 into 8. This comes out to be 240 meters. Let's calculate the area of shape B. Very, very easy again. 1 upon 2 into base, that is 4, into height, that is 16. So let's do that. The 1 upon 2 into base, that is 4, height is 16. 1, 2, this becomes 32. Add them two up. A plus B is your total distance. 272 meters is your total distance. Calculate the average speed. How do we calculate the average speed? Very easy. Average speed is what? Total distance over total time. Total distance over total time. What is the total distance? 272. What is the total time? 24. Divide both of them. 272 divided by 24. This comes out to be 11.3. Your average speed comes out to be 11.3 ms minus 1. Okay. A second car travels at a steady speed. It travels the same distance as the first car in the first 24 seconds of the journey. On figure 1.1, draw the speed time graph for the second car. Very easy. If you are traveling at a steady speed and you have to cover the same distance, you will travel at this average speed that you have calculated. If you travel at this average speed for 24 seconds, you will cover the same distance. So first of all, let's mark this. Okay. First of all, I can erase some things from here. Yeah. And where will be 11.3? Now, this is also a good thing to think about. If you see, there are 1, 2, 3, 4, 5 boxes. 5 boxes on the y-axis cover 4 units. One box will cover how many units? 0.8. So this becomes 8.8, this becomes 9.6, and 8.8 plus 0.8 is equals to 9.6 plus zero point 0.8, that is 10.4, plus zero point 0.8, that is 11.2. So your line will be somewhere here. Your line will be somewhere here, roughly a bit above. And obviously, you can draw a line like this. It should be a straight line you must draw with a ruler. I am being lazy here and not drawing it with a ruler, but you must draw it with a ruler. Okay, let's further move ahead. Okay, let's see this. The thinking distance traveled by a car between the time that a hazard is seen and the time that he applies the brake and the brakes are applied. Okay, the thinking distance is the distance traveled by a car between the time that a hazard is seen and the time that he applies the brake. Okay, the braking distance is the distance traveled while the car slows down to rest. Okay. Figure 7.1 shows the thinking distance and braking distance for an alert driver when the car travels at different speeds. Okay. Complete table 7.1. Okay. If your speed was 20, your thinking distance was 9. If your speed increased by 20, your thinking distance increased by 9. Again, a further 20 kilometer per hour increase in speed will increase the thinking distance by 20. Will increase the thinking distance by 9. Your final answer will be 27. Okay. Let's see part 2. The time it takes for the driver to react to the hazard is constant at different speed. Explain how the table show this. Because thinking distance is directly proportional. As you can see from the graph, thinking distance is directly proportional is directly proportional proportional to speed. And if you want to further explain it, since it is a two marker question, you will say equal increments, let's say 20 kilometer per hour increments in speed lead to equal increments in thinking distance, that is 9 meters. 9 meters. Okay, let's further move ahead. State what happens to the thinking distance and the braking distance when the driver is tired. The thinking distance increases since the thinking distance depends on the alertness of the driver and the braking distance remains same. Let's move on to the next question. Figure 8.1 shows a stationary horse and its rider about to jump over two fences. Okay, this is the rider, these are the two fences. Figure 8.2 shows a side view of the horse. Okay. On figure 8.2, draw and label the forces acting on the horses. Include the force that the rider exerts on the horse. Label this F. Okay. First of all, the weight of the horse and the person will act downward. There will be a contact force between the legs C and C. Between the legs, let's label this C1, C2 and C3. C's are contact forces. Weight is W is the, okay, let me write it here. Although the question hasn't asked, but let me write it for you guys. W is the weight of horse plus rider. C is your contact force. Okay. And what else do we have to mark? We have to mark the force that the rider exerts on the horse. Let me mark that with blue somewhere here. It will act somewhere here. F. Okay. Explain how Newton's third law applies to force F. Okay. The force that the rider exerts, a rider exerts on the horse is equal and opposite to the force that the horse acts or exerts on the rider, that the horse exerts on the rider. Simple as that. Let's further move ahead. Figure 8.3 shows a side view of the two fences. Okay, so one fence is like this Square. Basically, let me show you the fences. These are the two fences, okay? And this was the second fence, obviously. Since these are scanned images, some things are not scanned properly. These are the two fences. On each fence in figure 8.3, mark with across the center of mass. So this will be the center of mass, the geometrical center. And the center of mass of the second fence will be lower because much of its mass lies in the bottom part. Explain why a wider base makes the fence more stable. A wider base area, a wider base area means that upon a slight tilt, upon a slight push, or you can say tilt, slight tilt or push, the weight will still remain, will still remain inside the base area, inside the base area, making the fence stable, making the fence more stable, you can say. Let's move on to part C. The total mass of the horse and the rider is this. As they approach the fence, the horse and the rider have a total kinetic energy of this. Okay. You have to calculate their speed. Do you remember the formula for kinetic energy? Kinetic energy used to be equal to 1 over 2 mv square. Kinetic energy is 4000. 1 over 2. What is m? 520. What is velocity square? We have to calculate that. 520 divided by 2, 4000 divided by this answer taken under root. The velocity comes out to be 3.92 ms minus 1. Simple as that. Let's see this. The center of mass of the horse and the rider is 1.4 meters above the ground. Okay. The maximum gravitational potential energy gained by the horse and the rider as they jump over the fence is this. Okay. Calculate the maximum height above the ground of the center of mass during the jump. Okay. So the gravitational potential energy is 3000 joules. Formula of gravitational potential energy is mgh. Do you have the mass of both the rider and the horse? Yes, 520. Do you have g? Yes, that is 9.8. 520 into 9.8. Can you calculate the height of the jump? Yes. 3000 divided by 520 into 9.8. This comes out to be 0.589. Height comes out to be 0.589. What was the initial center of mass height? 1.4. Add the 2 to get the total height. Add the 2 to get the total height. Initially, the center of mass was at 1.5, 1.4 meters. Now you have jumped this amount of height. So you will add both of these two, 0.589 plus 1.4. This comes out to be 1.99, I would say. 1.99 meters. Simple as that. Let's move on to the next question. Okay, let's look at this question. A bus leaves a bus stop at time t is equals to 0 and travels along a straight horizontal road until it reaches a second bus stop. Okay. Figure 7.1 is the distance time graph for the bus between time t is equals to 0 and time t is equals to 60 seconds. Okay. The road on which the bus is traveling is straight, except for a short curved section. The bus travels around this circular curve between time t is equals to 21 seconds till time t is equals to 24 seconds. Okay, perfect. I guess 21 is here and 24 is here, just for if we need in the future. Describe how the motion of the bus between time t is equals to 0 till 10 seconds differs from its motion between time t is equals to 25 and 40 seconds. Okay. 0 till 10 seconds, you have this thing. Somewhat like this. Yeah. 0 till 10 seconds, you have an increasing curve. And from 35 to 40, you have somewhat like this. Let me choose a different color. This is your 35 starting point. And oh, let me zoom in a bit. Let's take it from here. Yeah, this is your 35 to 40, somewhat like this. Let's erase some extra highlighting from here and mark it in a correct manner. Starting from here, and like this. Okay, perfect. 35 to 40, you have a decreasing curve. 0 to 10, you have an increasing curve. Perfect. So, first of all, remember that the gradient of distance time graph is equals to speed. If you have an increasing curve from 0 to 10, that means what? Your speed is increasing. Because if you have an increasing curve, that means your gradient is, this is an increasing curve. And for an increasing curve, the gradient increases. As gradient increases, the speed increases. So you can write here from t is equals to 0 till 10 seconds, the gradient increases, hence speed increases. Hence, what is this? This is a bus. The bus accelerates. You will say the bus accelerates. Okay. But further, you can say that the bus is starting from rest and reaching a constant speed. You can say the bus is starting from rest at t is equals to 0 seconds. Simple as that. Okay, what further can you write? You can say from 25 to 40 seconds. You can say from, let's do it with a different color. Let's make it a little beautiful. From time t is equals to 35 to 40 seconds, the gradient decreases. And as the gradient decreases, what will happen? The speed will decrease. As the speed decreases, this means the bus is decelerating. Decelerating. Last point. What can you add here? At time t is equals to 4 seconds, or at time t is equals to 40 seconds. Let me show you one thing. At time t is equals to 40 seconds, can you visualize this? This entire horizontal line after t is equals to 40 seconds. This is a horizontal line. Here gradient will be 0. Hence your speed here will be 0. That means at t is equals to 40 seconds, you are coming at rest. So you can write this as well. Let's zoom out a bit. You can say at t is equals to 40 seconds, the bus comes at rest. Simple. Let's further move ahead. Determine the maximum speed of the bus during 60 seconds. Very, very easy. If you can see here, after increasing the speed for 10 seconds, the bus reaches a maximum speed. The bus reaches a maximum speed, or you can say a constant speed, represented by this line. Represent, although I think this color is pretty absurd. Let's take a lighter color. We haven't used green, right? So let's use green. So the bus is moving at a constant speed in this region. Why? Because in this region, you have what? In this region, you have a straight line graph on the distance time graph. So let's highlight it again. Let's not overlap, otherwise, you guys will think something else. So, yeah. So, this is the period in which the bus is traveling with a maximum speed. What can you do to calculate the speed? You know, gradient of distance time graph is equals to speed. So, let's take 2 points to calculate speed. One beautiful point is this, because this can be easily read. This is 30, this is 300. Which other beautiful point can I take here? Which one should I take? Uh, do we have any good point? Yeah, see this point. This is also a good point, although not that good, but this is time 13, distance 100. You have 2 points. Can you calculate the gradient? Yes, surely you can do that. 300 minus 100 divided by 30 minus 13. This comes out to be 200 divided by 17. The speed comes out to be 11.8 ms minus 1. This is your maximum speed. Let's write it here. 11.8 ms minus 1. You have to calculate the average speed. What have I told you? Average speed is equals to what? Average speed is equals to the total distance divided by the total time. Average speed is equals to the total distance divided by the total time. What is your total distance that you have covered? You have covered the distance up till here. That is 390. What is the total time? 60. Can you calculate the average speed? Yes. 3. Oh, we have to calculate. Oh, there is a thing that we have missed conveniently. You have to calculate the average speed between the first bus stop and arriving at the second bus stop. So basically, we are arriving at the second bus stop when time t is equals to 40 seconds. Why? Because at 40 seconds, the bus comes at rest. So your time will be 40, not 60. Why will your time be 40? Because you are arriving at the second bus stop at time t is equals to 40 seconds. 390 divided by 40. This comes out to be 9.75 ms minus 1 is your average speed. Let's zoom out a bit. State how velocity differs from speed. Velocity has a magnitude and direction. Has a magnitude and direction, whereas the speed only has a magnitude. Whereas speed only has a magnitude. Only has a magnitude. Simple as that. Let's further move ahead. There are three periods during the 60 seconds when there is non-zero resultant force acting on the bus. Okay. Complete the statements to indicate these three periods and state the direction of these resultant forces in these periods. From time t is equals to 0 till time t is equals to 10 seconds. The direction of the resultant force is forwards. Why? Because this causes an acceleration. Between time t is equals to, you can say to 10 to 35 seconds. Yeah. You can say from 10 to 35 you have a straight line. The speed is constant. So the direction of resultant force is perpendicular to the motion. And from time t is equals to 35 till 40 seconds, since we are decelerating, the direction of force is backwards. Simple as that. During the journey, air resistance acts. During the journey, the air resistance acting on the bus varies. Okay. State why the air resistance changes during this journey. Air resistance changes. Air resistance changes because speed changes. The speed or velocity changes, anything will work here. On figure 7.1, mark and label within M a time when the air resistance has a maximum value. Air resistance has a maximum value when you have reached a constant speed here, somewhere here. You can mark anything in the green line. Any point in the green line will work. Let's further move ahead. Figure 1.1 shows part of the speed time graph for an athlete in a race. Okay, this is for an athlete in a race. Let's zoom in here. This speed is 9. Just so that we need in the question, we will know this is 9. During the race, the acceleration of the athlete is uniform in the first 2 seconds. State how the graph shows that the acceleration is uniform. Very easy. We know gradient of speed time graph is acceleration. And since we have a straight line, we know the gradient will be constant. Hence, the acceleration is constant or uniform. So, how will you write it? The graph is a straight line gradient or m is equals to constant. You can write gradient as well, that will give a better impression. Hence, acceleration is uniform. Simple. Determine the distance traveled by the athlete in the first 2 seconds. We have to calculate the distance traveled by the athlete in the first 2 seconds, basically the area of this triangle. Okay, so 1 over 2 into 2 into 9. 2 and 2 gets cancelled out. 9 meters is your distance traveled. Yeah, 9 meters is your distance traveled. Okay, let's further move ahead. From time t is equals to 5.5 seconds, the acceleration of the athlete decreases. Okay, the acceleration decreases. Can you see here? Acceleration decreases, but you are not decelerating. At time t is equals to 5.5 seconds, the athlete reaches a maximum value of 12 ms minus 1. So let's make that. Let's first of all make that. So from 2 to 5.5, 5.5 will be somewhere here. At 5.5, it reaches a value of 12. So somewhere here. Let me mark a much lighter point so that we get a correct graph. Somewhere here. Somewhere here. I hope you get it. Once you have this point, you will draw a decreasing curve. Why will you draw a decreasing curve? Because your acceleration is decreasing somewhat like this. Then what next you have? From time t is equals to 5.5 seconds to 8 seconds, the athlete travels at 12 ms minus 1. Okay, so till 8 seconds you have a straight line like this. Obviously, you can draw it with a ruler. I am being lazy, which I shouldn't be. So, yeah, somewhat like this. This should be drawn with a ruler. And after 8 seconds, what do you have? Let's see, after 8 seconds, what do we have? After from 8 seconds to 11 seconds, the athlete decelerates, finishing the race at 10 ms minus 1. From 8 to 11 seconds. Okay. From 8 to 11 seconds, you are coming at a deceleration of 10. So you can draw your line like this. Yeah, this is your deceleration. Simple. So this is how you will solve this graph. Let's move on to the next question. Figure 9.1 shows a parachute is falling vertically downwards towards the ground. Okay. The downward force is 600 Newton. The upward force is 200 Newton. Okay. State what is meant by mass. Okay. Mass is the amount of, should I increase the thickness again? See, this is the main issue here. Amount of substance or amount of matter in a substance. Simple as that. The thickness has really made me forgotten about the actual question. Amount of matter in a substance. So yeah, that's the case. What is the definition of weight? Gravitational pull of Earth on an object. Okay. Calculate the acceleration of the parachute when the air resistance is 200 Newton. Very easy. The resultant force will be what? 600 minus 200, that is 400. What is your mass? 60 kg. So F is equals to ma. 400 is equals to the mass, that is 60, into acceleration. 400 divided by 60, this comes out to be what? 6.7. Acceleration is equals to 6.7 ms minus 2. The parachutist falls from rest at time t is equals to 0. Okay. He accelerates non-uniformly until it reaches a speed of 44 ms minus 1 at 30 seconds. Okay. So basically you have a speed of, let's mark these points. Basically, you have a speed of 44 at 30 seconds. So 30 seconds. Okay, so so on the x-axis, you have 10 boxes that cover 40 units. One box will cover 4 units. This is 20, 24, 28, 32. This will be between somewhere 30 and this will be your 30. Yeah. This point is what? This point is x-axis 30 and y-axis 44. Okay. So you will have a decreasing curve like this. You will have a decreasing curve like this. Why a decreasing curve? Why a decreasing curve? You might ask. Why a decreasing curve? Because whenever you are falling in air and you reach a terminal velocity, your acceleration continuously decreases. Okay, he accelerates non uniformly. Okay, at time t is equal to 40 seconds. Okay, the parachute opens. He decelerates for 4 seconds. Okay. So from 30 seconds to 40 seconds, he is falling at the same speed somewhere. Something like this. Okay. And at 40 seconds, his parachute opens. He decelerates for 4 seconds, reaching a smaller terminal velocity of 5 ms minus 1. Okay, so he decelerates for 4 seconds, reaching a velocity of what? 5. Okay. So 5 will be somewhere here. Uh, yeah. And this will be your 44. So basically this point is 44 and y-axis में 5. Can you draw? Yeah, you will draw a line, or you can say, first of all, let me erase this point and let me write it above here. Let's write it here 30 slash 44. Let's make a deceleration thing. Something like this. This can be a curve, this can be a line, this totally depends on you. Let me decrease the thickness and let's make a line so that let's make a curve instead. Yeah, something like. Oh, what's happening? Let's make a curve like this. Again, it is wrong. It should not go backwards actually. Something like this. Yeah, this is your curve actually. Now, what else is the examiner saying? He falls at this speed until he lands on the ground at 200 seconds. Okay, so he continues to fall at this speed. You will draw a horizontal line like this here. So let's draw a horizontal line at 5. Somewhat like this. Yeah, this is your horizontal line at 5. Obviously, you will have to draw with the scale. Calculate the average deceleration from 40 to 44 seconds. So your initial velocity was 30. As far as I remember, yes. No, your initial velocity was 44. Yeah, initial velocity was 44. And your final velocity is 5. And the time taken is 4 seconds. Can you calculate the acceleration? V minus u divided by t. V is 5, u is 44 divided by t, 39 divided by 4. This gives you a value of negative 9.75. Since deceleration is already written, it has accounted for your negative sign. 9.75 ms minus 2 is your answer. Explain in terms of the forces involved. Okay. Okay, we have to explain in terms of the forces involved why the parachutist reaches a terminal velocity at t is equals to 30 seconds. Why? Because air resistance equals weight equals weight. And if you are a further good student, you can write what? Resultant force decreases to 0. Decreases to 0. Okay, the parachutist decelerates when the parachute opens. Why does the parachute decelerate when the parachute opens? Air resistance increases drastically, and what happens? Resultant force starts starts acting upwards. This causes this causes acceleration to act upward, and the parachute is this causes acceleration to act upwards. This causes velocity to decrease or speed to decrease. Simple as that. The second terminal velocity when the parachute is open is smaller than the first. Why? Because now air resistance is equal to weight at a smaller value, is equal to weight at a smaller value. You can say that at a smaller value of velocity.